Welcome to this explainer. Today, we're diving straight into the hidden wealth right beneath our feet, the raw geological DNA that literally builds and powers the modern world. We're going to explore India's incredibly varied bedrock. Because of its complex geological structure, India actually has a rich variety of mineral resources, and these are primarily locked away in the ancient metamorphic and igneous rocks of the peninsular plateau. Seriously, this is the absolute foundation of India's industrial development. Okay, before we map out exactly where these treasures are hiding, let's just quickly nail down what our building blocks actually are. A mineral is fundamentally a natural substance. It can be organic or inorganic, but it absolutely must have definite chemical and physical properties. That precise composition is what makes them so valuable and, honestly, so unique. Keep in mind, the highest quality minerals are usually lower in quantity, and they are notoriously unevenly distributed across the map. So, here's our roadmap for today. We'll kick things off by decoding India's mineral wealth, map out the three great belts, and look at the metals building the nation. Then we'll shift gears into powering India with fossil fuels, explore the renewable energy revolution, and finally talk about sustaining our mineral future. Let's jump into Section 1, Decoding India's Mineral Wealth, the basic building blocks. So, the main split in metallic minerals comes down to physical and chemical traits. On one side, we have ferrous minerals, and ferrous basically just means iron. These obviously contain iron content, like iron ore itself and manganese, and they provide this incredibly strong base for metallurgical industries. On the flip side, you've got non-ferrous metallic minerals. These don't have iron content, but they're equally vital. Think of things like copper and bauxite. Now, while India is exceptionally well-stocked when it comes to ferrous minerals, we're actually pretty poorly endowed with non-ferrous ones. Well, with the notable exception of bauxite, of course. Moving right along to Section 2, the three great belts, India's geological treasure chests. What's wild is that these minerals aren't just scattered randomly across the country. They're actually heavily concentrated into three distinct regions. In fact, the vast majority of India's major mineral resources occur east of a line linking Mangalore and Kanpur. The northeastern plateau is incredibly diverse. It's just packed with iron ore, coal, manganese, bauxite, and mica. Down in the southwestern plateau, you've got a rich supply of ferrous metals and some coal, but it kind of lacks the heavy diversification we see in the northeast. And finally, the northwestern region up along the Aravalli and Rajasthan and parts of Gujarat, that area is known for copper, zinc, extensive building stones like sandstone and marble, and crucially, petroleum deposits over in Gujarat. Now, I want you to think about this for a second. Why is the steel industry, the very foundation of our modern buildings, our cars, our infrastructure, so heavily concentrated in the northeastern plateau, covering Jharkhand, Orissa, and West Bengal? Well, it comes down to a beautiful geological coincidence. You have world-class iron ore mines sitting in incredible proximity to vast energy-rich coal fields. That closeness drastically cuts down on transport costs, making it the perfect environment for heavy metallurgy. All right, Section 3, metals building the nation, the heavyweights and the wires. 20 billion tons. Let that sink in for a moment. That staggering number was India's total iron ore reserve back in 2004 to 2005. So yeah, India is endowed with fairly abundant resources here, boasting the largest reserve of iron ore in all of Asia. What's even better is that the main types found, hematite and magnetite, are of such superior quality that they are in massive demand in the international market. And a whopping 95% of these reserves are clustered in states like Orissa, Jharkhand, Chhattisgarh, Karnataka, and Goa. But building a nation takes way more than just iron, right? We have to give a shout out to the non-ferrous champions. Bauxite, mostly found in tertiary deposits and laterite rocks, is the vital ore used to manufacture aluminum, and Orissa is the undisputed king of production here. Then we have copper, highly malleable, ductile, and an absolute necessity for the electrical industry. In fact, it's very likely inside the device you're using to watch this explainer right now. The major copper deposits are found in places like the Singhbhum district in Jharkhand, Balakhat in Madhya Pradesh, and Junjanun and Alwar in Rajasthan. Oh, and we definitely can't forget non-metallic wonders like mica, heavily produced in Jharkhand. It's totally indispensable for electronic industries because it can be split into these incredibly tough, flexible, and ultra-thin sheets. Section 4, powering India with fossil fuels. Think of this as the metabolism of development. So looking at coal, a massive 80% of India's deposits are the bituminous type, specifically of a non-coking grade. As we know, coal is an essential fossil fuel, used extensively for thermal power generation and smelting that iron ore we just talked about. and over 97% of these coal reserves occur right in the valleys of Damodar, Son, Mahanadi, and Godavari. The Damodar Valley actually holds the most important Gondwana coal fields, which includes Jharia, that's the largest coal field, and Raniganj.
Beyond coal, we've got the other conventional energy titans. Petroleum, right? Essential for all our internal combustion engines. Systematic exploration didn't really take off until the Oil and Natural Gas Commission was set up in 1956. Actually, before that, Digboy in Assam was literally the only oil-producing region. Today, we've got major operations in Gujarat and the offshore Mumbai High, supported by 18 refineries across the country. We've also located exclusive reserves of natural gas along the eastern coast and offshore. Plus, nuclear energy has emerged as a seriously viable source. That's powered by uranium found in the Darwar rocks across states like Rajasthan and Jharkhand, and thorium obtained from monazites in the beach sands down in Kerala and Tamil Nadu.
Section 5. The Renewable Energy Revolution. The Infinite Turning Point. So here's the reality. We face a necessary and urgent transition. Conventional fossil fuels are exhaustible resources. That means they take a geological age to develop, and they simply cannot be replenished once we use them up. Plus, let's be honest, traditional methods of using them generate enormous waste and major environmental problems. Non-conventional energy sources, things like solar, wind, hydro, geothermal, and biomass, are exactly the opposite. They are inexhaustible, more equitably distributed, sustainable, and eco-friendly. 50,000 megawatts. That is the country's potential for wind power generation alone. Mind-blowing, right? The Ministry of Power estimates that we could easily harness a fourth of this to drastically lessen the burden of oil imports. Wind energy is absolutely pollution-free and inexhaustible, and we're already seeing incredible progress. Just look at Asia's largest wind power plant situated at Lambay in Gujarat, which capitalizes on the highly favorable wind conditions sweeping across Gujarat, Rajasthan, Maharashtra, and Karnataka. But wind is really just scratching the surface. India is actively tapping into a whole multitude of infinite sources. Take solar energy, tapped via photovoltaic cells or thermal technology. It's remarkably efficient, actually 7% more effective than coal or oil-based plants. And the western parts of India have massive potential for this. We're also looking to the oceans, where large tidal waves along the west coast offer immense, albeit underutilized, energy potential. We're tapping into geothermal energy, literally using the heat of magma from the Earth's interior, with a plant already commissioned up in Manakaran in Himachal Pradesh. We're even getting into bioenergy, turning agricultural residue and municipal garbage straight into power. A perfect example is the Okla project in Delhi, which brilliantly converts municipal waste directly into energy. Which brings us to our final part, Section 6, Sustaining Our Mineral Future, Integration and Conservation. This is the core dilemma of sustainable development, isn't it? Integrating our quest for economic growth with environmental reality. Because all these minerals took incredibly long to develop geologically, they don't have a second crop, as they say, they are strictly exhaustible. We absolutely have to embrace conservation. That means actively developing those inexhaustible alternative energy sources we just discussed, so we can replace fossil fuels. For metallic minerals, especially the scarce ones like copper, lead, and zinc, we've got to heavily rely on recycling scrap metals. We need to find substitutes, and we need to reduce the export of strategic minerals so our existing reserves actually last for future generations. The wealth beneath our feet undeniably built the nation we know today, but how we choose to extract, consume, and eventually replace these resources, well, that will entirely dictate our tomorrow. How are we going to balance the rapid industrialization of over 1 billion people with the urgent need to conserve our geological foundations? I'll leave you with that thought. Consider how we can all participate in conserving our exhaustible past while building a renewable future. Thanks for joining me on this explainer, and as always, keep questioning the world around you.